We will study direct form 2 structure of IIR system. It is an alternative structure to direct form 1 structure. Again considering transfer function h of z of IIR system, h of z is equal to y of z upon x of z, that is equal to b naught plus b1 into z raised to minus 1 plus b2 into z raised to minus 2 plus and so on up to bm into z raised to minus m divided by 1 plus a1 z raised to minus 1 plus a2 z raised to minus 2 plus and so on up to bn z raised to minus n. Now we will write y of z upon x of z as w by z upon x of z into y of z upon w of z. Here w of z and w of z will cancel. Once again we get y of z by x of z. But here some mathematical manipulation is to be made, where w of z upon x of z, from this expression I will take w of z upon x of z as 1 upon denominator only, that is 1 upon 1 plus a1 z raised to minus 1 plus a2 z raised to minus 2 plus and so on up to bn z raised to minus n. Y of z upon w of z will take as numerator, that is b naught plus b1 z raised to minus 1 plus b2 z raised to minus 2 plus and so on up to bm z raised to minus m. On cross multiplying we get W of z plus a1 into z raised to minus 1 into W of z plus a2 into z raised to minus 2 into W of z plus and so on up to bn into z raised to minus n into W of z equal to x of z. Or we can simplify for W of z and write W of z equal to x of z minus a1 z raised to minus 1 W of z minus a2 z raised to minus 2 W of z minus an z raised to minus n W of z. We will number the equations for our reference purpose here. You call this as equation 1, this as equation 2, and we will write here on cross multiplying equation 1 we get now I will call this as equation 3. Next, write cross multiplying equation 2 we get y of z equal to b naught into W of z plus b1 into z raised to minus 1 into W of z plus b2 into z raised to minus 2 into W of z plus dash 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 bm into z raised to minus m into W of z. Let us call this as equation 4 now. Equations 3 and 4 represent the IIR systems in Z domain. And can be realized by a direct structure called direct form 2 structure as shown in figure below. Now using equation 3 we will obtain W of z, and then using W of z in y of z, we will get y of z. Then using W of z in equation 4, we will get y of z. Here I will take x of z. Coefficient of x of z here is 1 and there are no delays. So I will take it directly here at this point. Second term we will see now. In the second term, W of z delayed by one sample and multiplied with A1 we are having. So now what I will do is, I will show W of z here. I will show W of z here. And this is to be delayed by one sample. For that, we will take one sample delay. And then it is to be multiplied by a constant minus A1. So minus A1 I will show here. And this is to be added to x of z. So this is one adder here. This is also one adder here. So here what we are getting? Here we are getting minus A1 z raised to minus 1 W of z. Next term in the equation is minus A2 z raised to minus 2 W of z. Z raised to minus 2 we can obtain by delaying W of z 2 times by one sample. So here we have already delayed by one sample. Next delay is shown here now. And here we get gain. That gain is minus A2. Now I will show here dash 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 z raised to minus 1, and here I will show the gain, and minus an I will write here. Dash 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 z raised to minus 1, gain is minus an, and its output I have to add to I have to give as input to the adder here. And I will join this point to W of Z. And I will join this line to W of Z. Next, for getting Y of Z, I have to make use of W of Z. You can see the equation here. Y of Z is B0 into W of Z plus B1 into Z raised to minus 1 W of Z plus B2 into Z raised to minus 2 W of Z plus and so on up to Bm Z raised to minus M into W of Z. So here now W of Z we are having. I will multiply this by B0. Output here is B0 into W of Z. The second term is B1 Z raised to minus 1 W of Z. W of Z into Z raised to minus 1 we are already having at this point. And this output is to be multiplied by B1. Similarly, B2 into Z raised to minus 2 into W of Z we need. So I will tap the output here. And here I will show constant as B2. Finally, we will be having here Wz into Z raised to minus M, like in this last term, and this product is to be multiplied by Bm. So I will show the constant here as Bm. Now these all must be added. Plus here, and plus here. Plus means what? Adders. Now this is required Y of Z. Now this structure is called as direct form 2 structure of IIR system for n equal to m. What is this? This is, what is this? This is direct form 2 structure of IIR system for n equal to m. We can get direct form 2 structure of IIR system by making use of direct form 1 structure. For that, what we have to do is shift this entire part here to the left and shift this entire part here to the right, and then after delay units here we are having points, that is output points, and here also we are having after delay units output points. After first delay unit point and after first delay unit point, we have to connect together. Similarly, the points after second delay units we have to connect together, and so on. That will become the direct form to structure. While solving example, I will show how to do that. Now we will take up examples to realize the given IIR systems. Example 1. Obtain the direct form 1 direct form 2 realizations of the LTI means linear time invariant system governed by the equation y of n equal to minus 3 by 8 y of n minus 1 plus 3 by 12 y of n minus 2 plus 1 by 64 y of n minus 3 plus x of n plus 3 into x of n minus 1 plus 2 into x of n minus 2 solution. First we will realize direct form 1. Given y of n equal to minus 3 by 8 y of n minus 1 plus 3 by 12 y of n minus 2 plus 1 by 64 y of n minus 3 plus x of n plus 3 into x of n minus 1 plus 2 into x of n minus 2. On taking Z transform of y of n, we get y of z equal to minus 3 by 8 into z raised to minus 1 into y of z plus 3 by 12 z raised to minus 2 into y of z plus 1 by 64 into z raised to minus 3 y of z plus x of z plus 3 into z raised to minus 1 into x of z plus 2 into z raised to minus 2 into x of z. Now we will implement this y of z expression. So x of z here and y of z here are shown input and output. Input x of z is to be added to 3 into z raised to minus 1 into x of z. So here I will show one plus sign, and from here I will tap x of z, one delay unit, and then gain I will show here as 3, and I will show here plus sign. So this term and this term here I have obtained. Next I have to obtain 2 into z raised to minus 2 into x of z. I will delay by 1 unit here because already x of z is delayed by 1 unit here. Total delay will be now 2 units into constant term is 2. So all x of z terms are over, add these. So here we get x of z plus 3 into z raised to minus 1 into x of z plus 2 into z raised to minus 2 into x of z. Now I have to add this summation obtained here to y of z and delayed Now the summation obtained here I have to add to the delayed y of z terms. If you remember basic structure, then you can do very fast, otherwise it will take lot of time. First term is z raised to minus 1 y of z into minus 3 by 8. Y of z is here. I will take the tapping. Here I get z raised to minus 1. And here I will show one gain box. In the gain box I have to show now minus 3 by 8. And here one plus sign. Next term is z raised to minus 2 into y of z into 3 by 12. Another z raised to minus 1 here. So y of z into z raised to minus 2 I will get at this point. That is to be multiplied with plus 3 by 12. And from here the output should be connected to adder. Last term is y of z into z raised to minus 3. So y of z into z raised to minus 3 I will get by putting here one delay unit. And this is to be multiplied by what? 1 by 64. So 1 by 64 I will show here. Now I will connect the output to the adder as input. Here also I will do the same thing. Now y of z is ready for us. So output here is minus 3 by 8 z raised to minus 1 y of z plus 3 by 12 z raised to minus 2 y of z 1 by 64 z raised to minus 3 y of z, and here output is 3 into z raised to minus 1 into x of z. Output here is 2 into z raised to minus 2 into x of z. Next, we will draw direct form 2 structure, but using direct form 1 structure only, as I explained previously. What I explained there? Bring this entire part to the left, take this entire part to the right, and then connect the points after first delay unit together, the points after second delay units together, and if any points are left, you keep them as they are. Shall we do that now? Okay. Now write here direct form 2 structure. Write at the center W of Z and see how many delay units are there in direct form 1 structure. Highest number of delay units you have to count here. Highest number of delay units are 1, 2, 3, and here it is 2. So among 3 and 2, 3 is highest. You take it. And from the W of Z point, you show 3 delay units, Z raised to minus 1, Z raised to minus 1, and Z raised to minus 1 delay unit. Next, you make use of this point as common point, this point as common point if necessary. Here you show x of z, here you show y of z. Now bring from direct form 1 the part on RHS to the LHS and take part on LHS to the RHS. If you do that, you will get minus 3 by 8, three by 12, and 1 by 64. For all these lines you can show arrow marks. And then summer or adder you have to show here. On right hand side you show part which was there on left hand side in direct form 1 structure. After first delay unit, the gain there was equal to 3. After second delay unit, the gain was there equal to 2. Now show here one plus. Now show here adders, connect it to the second adder from the bottom. Here also you have to show one adder now. Show this here. And W of Z you connect here. Now this is direct form to structure. Now this is direct form to structure. Dear students, I stop the class here and continue in next class with remaining types of realizations of IIR systems. Thank you.